In a recent video, I talked about the new Russian VK-1600V engine, which is preparing to lift the Ansat and Ka-226 helicopters into the sky. This engine is not very powerful and is as simple as possible. So simple that some people actually got bored. Well, it's time to add some spice, because the VK-1600V has a brother, more powerful, complex, and curious. Hello aviators, Sky here, and I present to you the VK-1600V. In the story about the VK-1600V, I talked about light helicopters and their adventures in the USSR and Russia. In the case of the VK-1600V, we are talking about medium helicopters, and their history is simpler. There were practically none. Light helicopter transportation was carried out by the Mi-2, weighing about 3.7 tons, and a step higher is the Mi-8, a workhorse that flies anywhere and anytime, and is perceived by many as a kind of minibus. But actually this minibus is a hefty 12-ton helicopter like the Sikorsky S-92, and it is very difficult to call it a transport slightly larger than the Mi-2. In situations where a helicopter with a carrying capacity of more than 4 tons carried 10 passengers and 5 suitcases, economists cried and asked to make something more optimal. And the solution to this problem was supposed to be the brainchild of the Klimov Design Bureau, the Ka-60, which a little later grew into the current Ka-62. And this project became a great long-term construction. There were many reasons for this: lack of funding, project stops, engineers being busy with more interesting programs. Demand was also small. In an open-world market, many operators without bothering went to foreign manufacturers, who offered excellent machines for every taste. In addition, the Ka-62, like its peers, turned out to be very dependent on foreign suppliers. A significant part of its components were purchased abroad, which cut off the interest of government agencies. And then we found ourselves in 2018. As part of several programs of the notorious import substitution, various components of the helicopter began to be replaced with domestic ones. And of course the main one was the engine. The power plant of the Ka-62 was a pair of Safran RD-3G turboshafts, and the fiery French were to be replaced with a new engine that met modern requirements. The United Engine Corporation, UEC, has finally plucked up the courage to enter one of the largest and most competitive niches in the market for turboshaft and turboprop engines, in which all the large and toothy shocks are present. By 2019, the project was officially initiated and implemented within the walls of the Klimov Design Bureau, located in St. Petersburg. Yes, the Klimovs were working on 2 projects at once. One team was making the VK-1600V, and the second, today's hero. Okay, enough history. It's time to look at this piece of engineering. Standing before us is the VK-1600V, the prototype, which is now being actively tested on stands, assembled and disassembled, a live test model. The general concept of creating the VK-1600V is similar to its brother. The engine should be quite simple, cheap to operate, economical, and reliable. The general design is more or less classic. Air enters the engine through the annular air intake, is pressurized by the compressor, ignited in the counterflow combustion chamber, rotates the compressor turbine driving the engine systems, and rotates the free turbine, which transmits rotation to the transmission and ultimately to the rotors. But the power here is serious. In cruising mode, it is 600 horsepower and 900 horsepower. Yes, there are 2 cruisers. At takeoff, it is 1400 horsepower, plus emergency mode, when the engine can be cranked up to 1750 horsepower for 2.5 minutes. Unlike the small turboshafts, which for the sake of optimization are as narrow as possible and differ little from each other, engines with power ranges like the VK-1600V are more complex, and designers have some room for creativity. There are different dimensions and layouts, assemblies of different types of stages, axial compressors, centrifugal ones, whatever your heart desires. So engines from different manufacturers are slightly different in design. In the case of the VK-1600V, the engine builders, while maintaining a generally simple layout, installed a 2-stage compressor, two centrifugal blocks, behind the counterflow combustion chamber there is a two-stage compressor turbine, and behind them a two-stage free turbine. The Klimovs did not come to the 2-2-2 scheme immediately, but as a result of a large amount of research that showed, for example, the benefits of installing paired stages instead of single large ones. Firstly, a large turbine increases the size of the engine, and secondly, there is a not entirely obvious conclusion. Two stages in total are lighter than one. It would seem strange, but if you look closely at the disc itself, you would notice that a significant part of it is practically monolithic metal, and in a large disc there is a lot of this metal, which adds significant mass. Even with their small dimensions, these things are terribly heavy. Another useful solution from Klimov was the installation of cooled blades on the compressor turbine, which takes on most of the heat. Each blade has channels through which air passes to cool it. This allows to increase the temperature at the outlet of the combustion chamber, increasing the efficiency of the system. The solution in engine building is not revolutionary and is quite actively used, but it is used mainly on large engines, and in the VK-1600V class it is considered a bit too complicated, so it is quite rare. The Klimovs decided to take a step forward here. There is a risk of complicating production, but the return could be decent. At the front of the engine there are auxiliary elements, transmission, cooling, fuel and oil systems, and so on. The automation here is also new. The digital engine control system FEDEC on the VK-1600V is the BARC-15V unit. The Klimovs did not complicate their lives here and unified the BARC-15V with the BARC-5V, which is also made by them for the VK-650V. The hardware and software are different, but externally it is difficult to distinguish them. They are practically the same black metal box. The weight of all this beauty is within acceptable limits, about 210 kilograms. The design is modular, which greatly simplifies its maintenance and repair. Also applied here is the concept of Russia's second resource management strategy, a modern technical support system for engines. The resource is decent, 3,000 takeoff flight landing cycles for the hot part and 6,000 cycles for the cold part. In general, the VK-1600V remains at the level of its colleagues. Nothing supernatural, but it should not be inferior in anything. Its dimensions are quite optimal. Again, it can be installed on the Ka-62 or other helicopters of this class without any modifications. For the sake of simplifying Klimov's adaptation to the new engine, in terms of dimensions and connection schemes, the VK-1600V was made very close to the RD-10 3G, so remotorization should go without problems. Now comes the obvious question. In the video about the VK-650V, I said that the engine is as simple as possible, and by adding modern solutions and technologies, Klimov managed to create it quite quickly. Work began in 2019, and certification is already planned for 2024. The VK-1600V is larger and more complex, and yet it is created at almost the same speed. The secret here is simple. The modern solutions used to create its little brother in the 1600s have been pushed almost to the limit. Digital design here is taken to the absolute level. Computer modeling, 3D, digital twins, everything is now on screens, no paper. Such solutions can significantly speed up work. The question may arise, here the potential was used to the fullest, but was it not the case for the 650? Why not? I don't know. It may be possible that there was simply not enough resources for both projects. All these methods simplify the overall work, but they need to be mastered first. At a minimum, highly qualified specialists are a hard-to-get asset. Additive technologies are also used extremely actively. In the process of creating demonstrators and prototypes, they printed everything they possibly could. And not only simple elements, but also complex parts made of heat-resistant alloys. About 70% of all casting on prototypes was done on a printer. Coupled with the fact that the engine was created on a computer from the very beginning, the transfer of documents to specialized production was quite simple, and they did everything quickly. It took 2 to 3 months to create parts, but if everything was done with a classic serial approach, the same result would have taken 10 months every time. Considering that during the testing process, parts were created, checked, rejected, and created anew, without 3D printing, the work would have lasted for many years. Thanks to all this, testing is being carried out much more actively than usual. To speed up work on the program, Klimov engineers built 2 test stands at once, now operating in parallel. Again, there will not be a huge number of printed parts in the series, or regulatory framework and certification of technologies are needed, and printing serial parts in large quantities is more expensive than doing it on a classic production line. At the same time, I would like to note an interesting test result. The printed parts have a very decent performance, and in theory, could be used on production motors. So the question here is not so much technical as economical. The engine at the moment continues testing on stands and is being prepared for installation on the Ka-62, now at the level of digital doubles and then live, with subsequent testing and certification of both the engine and the helicopter. Serial production should be deployed in 2025, and by 2026 we should see the Ka-62 with the VK-1600V engine in operation. The plans are ambitious. And ironically, the main risk for the VK-1600V, in my opinion, lies not in itself but in its client. While the 650 is planned to be installed on the Ansat and Ka-226T, that is, 2 helicopters at once, which are already being supplied and are in operation, the 1600s is planned to be installed on the Ka-62, on 1 helicopter, which is not yet mass-produced. To expand potential demand, there are plans to create a turboprop version, the VK-1600S, for small aircraft and local airliners. And the need for such devices is obvious, but again, there are a lot of factors that hardly depend on the engine builders. Aircraft, after all, are not their area of responsibility. Is there a risk that having made an excellent engine, Klimov will encounter insufficient demand? There is. You can't relax here. But the current situation can play into the hands of aircraft manufacturers. The domestic commercial market for the Ka-62 class helicopters was previously occupied by foreign machines, which are now obviously less available. Plus, after replacing foreign components with domestic ones, the Ka-62 will become much more interesting for government agencies. It's the same with airplanes. Annushka is of course our eternal love, but one day Grandma will have to retire. And here, engine builders and aircraft manufacturers will have to work hard. If planes with the VK-1600S turboprop also appear, then the demand will be great. Klimov will deploy a large production, and UEC will receive a live line of modern engines. As usual, we will draw conclusions in 10 years or so. On this, I think we can finish the story. Thanks to the Klimov Design Bureau for the demonstration of the demonstrator. We wish them good luck in implementing the project. And you aviation fans, comment what you think about the engine. And if you want to watch the videos early, see some exclusive behind the scenes content, or just support the channel, consider joining our Patreon community. Fast flights with good engines, and soft landings to you.